and then the discussion between what type of virtualization is Docker and how it is different from other type of virtualization. Then go through the Docker architecture, Docker ecosystem, and up to Docker ecosystem, we have this in the syllabus. But after that, there is some matter called DevOps, which after this course, what would you like to explore? I am going to talk about it. DevOps is not a part of this course. DevOps can be a part of software engineering course, but in future, you will be learning Git in the software engineering course. So that is also a part of DevOps. So with that, we will be ending today the complete discussion on virtualization. And from next week, we will have a topic on big data. So when was the Docker released? The Docker was actually released in 2013 by these two software engineers, Solomon Hykes and Sebastian Pal. They were facing the problem of previous system, like the things are not running from one image to others. From developer to tester, this problem was happening. So they themselves created a solution of it, and they made it open source. So the Docker is an open source centralized platform, and you can see that within 7 years, Docker is everywhere. Without Docker, hardly any industry is actually working. Everywhere they are using Docker. If it is really a small enterprise like 4 or 5 people, they may not be using Docker, but the moment you go to 20, 30 people size company, then the use of Docker. And now our students are also working on a Docker. They are submitting the assignment by Docker image. Okay, go. I don't have to worry about all the complication of compatibility. I created it. Now go run it wherever you want to run, right? Now Docker is an open source. They created it and made it open source, and now they are monetizing it also, but the code and everything is open source. They have a enterprise version, which is actually paid version, but there is a community version which is free. Most of the time, the community is good enough to work on. Now, Docker use container on the host OS to run the application. Means Docker itself does not have actual OS. Later on, I will tell you it has a small bit of amount of OS in it, but actually it does not carry the full OS. It uses the host OS to run the application. And Docker is written in actually in Linux. Docker has a very good compatibility with the Linux, and it runs on the Linux platform pretty well. For other version also, Mac and Windows also, they have the version Docker client for running on Mac as well as on Windows. For Windows, only Windows 10 they have. Windows 10 they have. They are all the 3 versions of Windows 10 they have a Docker client. It can be installed on any OS, as said, but Docker engine actually carries the native Linux distribution. And later on, we will see that why I am saying it. And Docker works very much better, less issues with the Linux platform. Some developer or some people have faced some problem with Mac or Windows platform, but with the Linux, it runs very smoothly. So Docker is actually written in a Go language. So Go is a language by Google, I think. And it is a special kind of language. On using that Go language, Docker is written. And Docker is actually a tool which performs the OS level virtualization. So I was talking about, you remember, OS virtualization and hardware virtualization. So Docker is basically an OS level virtualization. So what does it mean? So you have seen the VMware, right? Now in the VMware, you see we are installing this hypervisor EXXI, and this is the hardware, right? And this is a hypervisor, and on which we have to put OS, and then the VM is created. In this case, anything which VM needs, it has to go to the hardware. Means it has to ask here, and then ESXi, it will say I need a 2-core, 2 GB RAM, like 2-core, 2 GB RAM, right? And I need 100 GB hard disk storage. So once this has said, it is fixed. Once it will be assigned to it, this particular thing is going to hold it. So basically, whatever the capacity of the hardware is getting virtualized. And that's why the VMware is known as hardware level virtualization. But if we go to the Docker, in Docker, how the architecture is, it has a host which has a hardware. This is a host. And on top, we have this OS installed, the Linux, Windows, or Mac. On the OS, we have this Docker engine installed. Now, Docker engine itself does not have any OS. Whenever it needs any operating system, it actually demands from the base OS, which is host OS. And if it needs to create a container, it is going to pull the image and keep the image here. It is going to pull the image and it will keep the image here. It will pull the image and it will keep the image here. So when it pulls the image from a Docker Hub, so it will pull the image from a Docker Hub. And this image will be kept here, kept here, kept here. And then when it needs to make a container, it is simply going to run the image. And while in the image, it is defined that what is my hardware specification or anything is needed. I need 8 GB RAM or 2 core or whatever. It is going to ask from the host. So here it is actually the OS level virtualization. It is, and for anything, it has to actually go via the OS. So OS is actually getting virtualized. It doesn't carry its own OS. It is actually taking the OS from its. Now, Docker is written in Linux. And so on Linux, if you ask how much OS, I was telling you that the Docker does not carry any OS, right? But actually it carry around 5% of OS. So if Linux is 2 GB setup, so it is going to carry around 5% of 2 GB, like 100 MB of data, right? But if we go here, what is the problem it has? See, if we want to install the OS, it is going to eat up the whatever, like say, if I install the Ubuntu, right? It is going to eat up the space of whatever Ubuntu OS is going to take on this VM. So out of this, it is going to take certain space to install the OS, because here the OS are getting installed. But in case of Docker, it is an OS level virtualization. It is not actually installing the OS. It is only putting around 5% of the OS image, and remaining everything it is taking from the host OS. Now, how it is able to do it? Like the OS, why it doesn't need? It only carry a little bit, remaining all, because it's a Linux kernel base. So it has a good compatibility. Whatever is needed for Docker, it is going to keep in this 5%, and rest everything when it needs, it will simply take it from the host OS. Now, the question comes, what happened with Windows and Mac? I will be answering it later. Okay, what happened with Windows and Mac? Shall we start? Welcome back, student. Now, Docker is very much like a friend, Docker is very much like a friend who is going to ride in your own car, going to say that, okay, I don't like cars, but when they have to go, they're going to use your car. They will get a ride share from your car. And so Docker is very much like it. It is a very lightweight, doesn't carry OS. Whenever it needs an OS, it is going to say, okay, I need an OS, give me, because I want to be lightweight. So it's very much like a kind of friend who try to take ride on with others' car or other services. We all have a friend. Even I was sometime like that. Thank you. Now, advantage of Docker that we had seen in the case of VMware, whatever the hardware resources needed in the VMware or any virtual machine has to be pre-allocated: RAM, hard disk, number of cores. So everything is pre-allocated in the case of VM virtualization or hardware level virtualization. But in case of Docker, it doesn't ask anything in the beginning. When you pull a Docker image, it is just an image. It's like a photograph. It is not an active person. It is like a photograph which doesn't have any other than that image size. What is the image size? That is going to cost some space. Other than that, it is not occupying any kind of RAM or any kind of core or any kind of hard disk other than the size of the Docker image. So it doesn't require any pre-allocation of the RAM, and that's why the hardware resources is free all the time, and you use it whenever you need it, the Docker image when it needed. It gives continuous integration efficiency. That means later on, like it's like you make a cloth. Let's say when you make a cloth, you first cut the cloth into size, then you stitch it and then wear it, and you find out, okay, the size is little loose. You again measure it, okay, you have to cut back, you have to again stitch back or cut back and make it proper fit, right? So in the software development also, the continuous development and continuous deployment, continuous testing goes on. And that is called continuous integration. And with the help of Docker, it helps in getting a continuous integration. And for example, if you are building, let's say you build the container web app, and now I give a colloquium, okay? Your customer wants an web API, and where there will be a login page, and after that, there will be a e-commerce platform where the products are listed, right? Where products are listed, and then the product can be buy. So rather than building everything in the present agile kind of development platform, which actually called continuous integration efficiency, where a developer is going to first build the login page, user ID and password, and ask the customer to give a feedback. And the customer say, no, I want the image like here, or this like here, or this I want to be placed here. So in that stage already you get a feedback, and then you make the change and you build it and you send via Docker image that, okay, you run it and see. So they will say and can give a feedback. And then after that you go next stage, you build the product page and other things. So that is called continuous integration. And it actually Docker enables to build a container image, and the same image can be sent across and every step of deployment process, the same image can be used. Like any new development, I again create an image, okay, run it. Docker is less expensive compared to the VMware platform or other virtualization VM, because here you are not really taking the allocated RAM space. And if you go for a pay-per-use model also, you are only going to pay when the time you are using it. So it is less cost. And if we are using the Docker as an independent, like Docker Inc. platform, then the enterprise version expense. So the Docker has two versions. One is a community version, other one is an enterprise version. The enterprise version, you can keep your image private. Like I'm building a software or I'm building an app in a company. I don't want my competitor to know what are the different platforms or what are the different libraries I'm using it. So I would like to have an enterprise, and I want to keep my Docker image private, but I would also like to share my image with my team. So in that case, the one can take the enterprise version, and that is less costly compared to other facility available in the other prior to this, the Docker, like using a virtual machine and other thing. It is very light in weight. As I told you that it only carries 3 to 5% of the OS. But if it is a window, if I'm using a Docker engine on Windows OS, then it is a little bit bigger in size, like around 565 MB or something, because it has to carry part of the image of the Windows OS, and also it carries some part of the Linux kernel. So that's why it is a bit bulky, because Docker runs on the Linux. It is made on the Linux. So some compatible files and other supporting system it needed. So whenever you are installing a Docker client on a Windows platform, the size of the Docker client is a bit bigger. So in reality, it's very light in weight. It only consumes 3 to 5% of your, it carries only 3 to 5% of the OS and doesn't need a full OS. So it is light in weight. It can run on the both physical hardware and also on the virtual hardware. Like you can make a container on the virtual machine, or you can make a container on the physical hardware machine. Like when you install the Docker on your device on which you are doing the colloquium, you actually made a container on the physical hardware. But the same, you can make a container on the virtual hardware, like Azure has the container Docker platform. AWS, like Amazon, also have the container, like Azure has Azure Container Instances, ACI. AWS also have Amazon Elastic Container Services, ECS. So it can run on both the places. The good thing is that you can reuse the Docker image. For example, you created a container, right? Means you pull the image from Docker Hub, let's say DH Hub, Docker Hub, and you pull the image, and then you made some changes on it. You build an app on it, and then you can save it an image. Either you can push back to Docker Hub if you are using the public version or community version, or you can put into the private hub, and then this image can be reused to make other containers. So that's why it is very good that you can reuse the images. And if you have seen that it is take very less time to create a container. When you have already created the container, it just few seconds container is created, or even a small container requirement is a fraction of second it created. So these are the advantage of it. Now the question I was telling you, that what happened to the Docker on Windows, right? So for Windows, earlier they only had two compatibility, like you create a Docker, right? you install the Windows OS, and then you can put a Docker engine or client on it, or Docker daemon on it. So earlier it only used to have only the Windows 10 Pro and Windows 10 Enterprise Edition. Windows Home, the Docker support was not there. Only August 21 they given the support to Windows Home. But the thing is that this Hyper-V should be enabled. And Windows 10, if you go to the setting, you have there is a setting where you can enable the hypervisor. So if this two is there, then you can run the Docker on Windows also. But any other window like Windows 8 or Windows 2000 or any other window edition, Docker do not have client yet. Now, I was saying that Docker is a lightweight. So when it creates the Docker engine, so it does carry both, it both carries some part of Linux kernel and as well as some part of Windows to make it compatible to run on the Windows platform. So in case of Windows, the size of this Docker engine is little bigger, but it will run same as in the Linux. Like if you have created a container and you created an image of the Docker, you go to the Docker hub and you can pull to Windows also. You can pull to the window also and run it. You can pull to the same image on Mac. Most of the time on Windows and Mac, if you pull the same image, which can be created on Red Hat Linux, or REH, Red Hat Enterprise Linux version, RHEL, Red Hat Enterprise Linux. But then it can run anywhere. So Windows also it runs, but practically it doesn't carry the full OS. It carry a small part of it, because without OS, how container is going to perform its task. So that is the one thing. Now, running a container is very easy, right? Like there is this, in case of VMware or making a virtualization, where you create you put a hypervisor and then you install the OS and then you make a VM on it. It was difficult to actually share the VM. Like, okay, I share my VM. But in case of Docker, and it is actually an image, when we pull from Docker Hub, when we pull from Docker Hub, it is basically an image. When it is running, when we say run a Docker image, then only it is going to be called container. Until then, it is an image, and you can pull it and it keeps the image here. You pull it, let's say you pull Ubuntu type of image, it keeps here. You pull the CentOS, it keeps here. You pull some other Docker image, it is going to keep it here. So when you are going to run it, then it is going to create a container. Otherwise, it is an image. And so there was a question how VMs are getting shared. So in case of VM, they have to recreate the VM. But here, in case of container, it is getting transferred as an image. So it is very much like you actually create. So container is like an image. When it is created like an image, if I do this and I create image of my container, means like my image, so it will be like this. It cannot become like this, right? So, but you can make it a container and make the changes in this form, and you can again create an image of it, and then you can share exactly in this form to other person. So it is get transferred as an image form when it become container, when we are running it or using the Docker engine or Docker daemon. Okay, understood? The difference between the Docker is how it is getting shared an image. It's all okay. So now I said that it is an advantage. It is a lightweight. We can use the image, and it is take very less time to create a container. So now, what are the disadvantages? When someone asks you advantage of anything, and if have a little common sense, then it is very easy to say, oh, it is better than the previous technology. It is user friendly. It is cost efficient. It is fast. So this is 3-4 points you can anyway put it. Like anytime someone asks you what is the advantage of something, oh, it is user friendly, it is efficient, it is versatile, it is robust. This is very easy to put in, and some or other is going to match it. But Docker do have disadvantages. So what are the disadvantages? Like if we are looking for a really good graphical user interface, Docker still lacks the good graphical interface. You run using the CLI command line instances, Docker this, Docker that. So graphical user interface requirement, if someone has, that is a limitation of Docker. If we have too many containers, then using the Docker, it is difficult to manage. If you go to the Docker Hub platform and you simply type Ubuntu, you can see so many Ubuntu are there. And with the time, if you are working in a company where 15, 20 people are working on a platform and they're creating different kind of image, over the time 100, 200 Docker images will be there, and at that time it becomes very difficult to manage. There is a solution to manage a container which is called Kubernetes, and there are others also, but Kubernetes is one such way you can do the container orchestration, and that helps in managing the container. So Docker has an advantage, Docker has disadvantage that is getting solved by someone else called Kubernetes. Docker used to have more cross-platform compatibility. It is getting reduced a lot, but still sometimes cross-platform compatibility is seen for a larger application. For like in the colloquium, the TAs have told you that you can build in any OS and it can run on any other OS or any platform. It's usually true, but sometimes it can create, it is not completely fuss free. So that cross-platform compatibility sometimes is missing. Not most of the time, it actually is cross-platform compatible. The no solution for data recovery and backup. See, this is a problem of data persistency. If you think from the point of view, like there are workarounds, as one of the students have said in the learning feedback, that managed to run, use the data persistency. So, but directly, the Docker has data recovery and backup problem. There are workarounds to use it, make it a data persistent. And if your application allowed to do it, then it is okay. There's another risk is that one has to evaluate the security risk. Like if I'm moving my application to Docker, so need to evaluate what can be the risk of my application moving to Docker, which is a security related risk that need to be evaluated. It automatically does not come as secure. You have to know whether if I move my application to Docker, am I violating any kind of security related to my application or platform? And there is another disadvantage of Docker is that Docker may not be useful for every type of application. So keep in mind that not for all application, Docker can be useful. in general, it is very useful. As I was saying it, that usually if container is made with a window platform, and if it run on the window platform by the testing side and operation side, it does pretty well. But sometime because when we go for a larger application where more than 100 to 100 dependency is there, many libraries are there which is used by the bigger application. Imagine Adobe application, the Photoshop. Adobe has many software. Let's say Photoshop. Now Photoshop comes with lots of libraries and a lot of dependency. It may happen that sometime, some version, sometime it is going to create problem if it is built on Windows and it running on Linux. With the time, it is becoming more stable across platform. Compatibility is getting reduced, but still sometime we get it. So the next is a Docker architecture. Docker architecture, we have used the Docker and without knowing what is a Docker architecture. So let's see what is a architecture of a Docker. So when we talk about the Docker, what happens is that there is a developer, right? Now, developer is going to make this requirement document like a Docker file, and that Docker file will contain all the required dependency and what the software is required. Everything will be written on it. Okay. So everything will be written on it, like I want Ubuntu, I want Python, I want some other Python library, this library, that library, that library. So the developer is going to write. And then it is going to create the image of this dependency, and it will name the image. It will give a name to an image, right? And that image, it is going to run it. So when it runs it, it will create, the container will be created, and it can run the application with all its dependency first free. Done, right? Now, this particular thing, which actually where you pull the image and you run the image, that particular, and create a container, that is known as Docker engine or Docker daemon. Nowadays, commonly we refer Docker. So when we say commonly Docker is the name of a company, but now wherever you see a Docker, practically we are meaning the Docker engine in that case, most of the time, or in proper technical term, it is called Docker daemon. Okay. And then once we created this image, we can put it to the Docker Hub. And Docker Hub is actually known as, another name is there, which is called Registry. So the developer created this Docker file, dependency, and whatever required. It created the image, and when it is run, it can create a container and the application will run. The same image can be saved to Docker Hub, and that Docker Hub image can be pulled by other people, and then a container can be created and it can be run. So one-time creation, one-time effort, and it can be used and by many times. And here, if some development happen, then this image will become image plus plus. This will become image 1.1. This was image 1.11. So this again can be saved as a container image or Docker image, and that can be used by other to make it, and that image can be put back to the hub, and it can be used by someone else and create a container. So this is what the very simple the Docker architecture, which has a very simple way to do it. That there is a Docker hub where the Docker images are kept. You can pull it, you can use it. If you run it, you can create a container and you can modify your container, or you can run the application without modifying it. The modified container, you can make it an image and can put back to the Docker hub and can be reused, both in a public way if we are using the community version, and a private way if we are using the enterprise version of the Docker. So far clear? So far clear? Okay. So now let's move back to what are the different ecosystem of the Docker. So how it is made, like this particular Docker file dependency is basically, it follows the layered file system where you have to write what just a lowered one, bottom up. Ubuntu I need Git, I need Chrome version, I need Python. So all this will be written, and one by one, it is going to pull and install, pull and install, and pull and install, and then it is going to run it. So you can see the sending build context to Docker daemon, and then it is saying that step 1 of 6 from Python version 3 it is installing, and like that it is going to install the layered by layer. It is going to install layer by layer, one layer, then another. Slowly it is going to build the full system. So all the dependency it is going to install one by one, and if any missing, it is going to pull back from it and do it. So Docker on concept is that it is a layered file system, and what it means that layer by layer, all the activity will happen. When we are creating a container, it is going to do all this installation layer by layer and then create a container of it. So if we talk about the Docker ecosystem, we have Docker ecosystem means set of software or packages, right? It is a set of software or packages in which you have a Docker client, you have a Docker daemon or Docker engine, or sometimes they call it server. We have a Docker hub, which also known as registry, then the Docker image. Docker image is basically a template, and then Docker compose, by which Docker template can be created. So what is a Docker daemon, which is the most important thing? Docker daemon actually run on the host OS. So what means I have a hardware on which I created the OS. I installed the OS. So this is hardware, and on top we install this Docker engine, right? So this actually running on the host OS. It does not have its own OS. It runs on the host OS. It is responsible for running the containers. It also is responsible to manage the Docker services, like when you say Docker run or Docker stop or Docker remove. So all this command used to manage the Docker services, Docker daemon does it. Docker daemon can also communicate with other Docker daemon. That means you can talk from one daemon to other daemon. So that also Docker daemon allow you to do it. Okay. Now the Docker client. So Docker client is basically it is a user interface, which is a command line interface, which can be used to talk to the Docker daemon. And Docker client uses commands and also the REST API. So REST API you can understand is restorable state transfer API. This is you can understand it's like an architecture by which the web kind of application is built, like client, server, all this. So it is an architecture, and if that architecture has some requirement, if that requirement is fulfilled, then using this, if any software is providing the REST API, then basically they are letting you make the web-based type of application, and it follows certain kind of things. So Docker uses the command and REST API to communicate with Docker daemon. So basically, it uses the REST API to talk from one Docker daemon to other Docker daemon, and that is, it is talking via the internet. So this is a web kind of architecture, the internet kind of architecture it is using to communicate from one to other daemon. When a client runs any server command on the Docker client terminal, the terminal sends this Docker command to the Docker daemon. So it is pretty simple that I am interacting with this client. In the client, I'm saying Docker run or Docker remove or Docker stop. So it is actually sending the command to the Docker daemon, and then the command is executed. It is also possible for Docker client to communicate with more than one daemon. That means here we have a Docker client, right? DCL, Docker client is there. It can communicate with more Docker daemon, not only one, more Docker daemon it can communicate. So at a time. So, and this is one good thing about the Docker, that it's not restricted to only communicating with one. Now, the Docker host. So what is a Docker host? Docker host is basically the host, this one, on which the OS is installed and Docker engine is installed or Docker daemon is installed. So this is known as Docker host. As you see, this is a Docker host. When we say Docker host, we are actually referring to the this hardware host on which Docker is hosted. And via this Docker, the host OS, it is interacting with the host hardware. So it is providing the environment to execute and run the application. So all this container, whatever it is saying that I want 8 GB Python, 50 GB. So I am faced with technology provides the benefit, also some challenges. So whatever container it asks, it is provided by the host. Docker engine provide via the host. It is going to talk to this OS, Docker host OS, and then this is given by this thing. It also contains the daemon images, container networks, and storage. So this host carry everything. When this image is pulled, it is kept here. So that actually reside on this host. So it provide all the networking, like one daemon are talking to other daemon, the Docker engine is talking to another Docker engine, that also is providing. Now comes the Docker Hub or Docker Registry. So Docker Hub is this world where all these Docker, public Dockers are kept. And also the private Dockers can also be kept there, but it is not visible to the public. So Docker Hub are of two types, or public registry or public Docker Hub and the private Docker Hub. The public Docker Hub is actually known as Docker Hub. Others are actually private, which comes with the Enterprise Edition. This is not available in the Docker Hub, but it is the service is provided by the Docker company, okay, where the images can be shared within the enterprise if we have the enterprise have the license edition. So in the hub, it is used to store and manage these Docker images. When you say pull Docker pull Ubuntu, then it is actually taking from this Docker Hub and putting on this container and pitching on this Docker engine, and when you run, it becomes container. Now, what is a Docker image? Docker images are actually read-only. You have to understand it is only a binary template, and it is a read-only. That means once an image is created, it cannot be changed. these Docker images are used to create the Docker container. We can change the image, but then you have to make it a container, and then whatever changes, if we again make it a Docker image, then that change will be saved. But as it is like a normal image. If you take a selfie or any kind of Wi-Fi, then whatever state the people were, it is stored in the image like that. So the Docker image is also the same thing. If at any condition the image was created, exact condition, the execution condition and app condition will be created as an image. So it is basically a single file. It is a single file with all the dependency and configuration required to run that particular program. What are the ways to create an image or pull an image? Basically, there are two ways to create an image. This and this. And there is one way to take an image, which is called pull the image. So pulling the image, you know that there is those Docker Hub, which basically, let me create. Right. This is a Docker container hub is there, which has how to create IAN. Okay, my cartoons are bad. So you take image from this Docker Hub, but if you want to create the image, it is created on the container. So if you have created the container, so with the container, when you say create the Docker image, then this Docker image will be created, and that image can be put back to Docker Hub, or it can be shared with others. We can also create the Docker from existing container. So I told you just the existing container that we pull the image, and from that we create the we make it run the container and create an image, right? Other way, we can create from the file. You know, we make a dependency file, and then when we run this, then it can be actually saved. It can be run in a container, and then it can be saved as an image. So this way also can be created. So there are two ways to create the image, and one way to pull an image, that is from Docker Hub. Container, the Docker container, you have already used it. Container basically holds the entire package that is needed to run the application. That means everything, the OS and the dependency library, dynamic link libraries, all the software needed for that application to run. So, but in other words, it is basically a template which says that what all I need to execute a particular program. So it will be run in a container. So whenever a container is created, it has to actually create the environment on which that particular application run, and all the information will be there in the image to make it. To know from the means, it is very much like a virtual machine, like it is, except we forget about what type of virtualization is used. Container also, and also the VM also actually helping you run the program. Container also helping you run the program. Container has its own benefit and disadvantage. VM also has its benefit and disadvantages, but they are something like similar. Image becomes, this is very important to know. The Docker image become container when they run it on the Docker engine. Before that, it is an image. Basically, the Docker image is a dead body. When it runs, then it container. So image is a dead body. If you run it, then it will be a container. Important. Okay. So there are these Docker commands are there. you know, like Docker image, you can see all the images present in your local machine. Docker search Ubuntu, then you can find the Ubuntu image on from the Docker Hub. This all is a command line prompt. The Docker pull CentOS, then you can download the image of CentOS from the Docker Hub to your local machine. If you say Docker run -it, the name, let's say the name of my image is Dilip. I want to name the image I am pulling to Dilip. Then it is going to give the name to the container. So container will have name Dilip. And then Docker service, Docker status, then you can see the, Docker service status, you can see the what is in the service is a start or not. Same, if I have named my as a Dilip, then it will start a container with a name Dilip. Then attach, go inside the container. This is very much like Linux PS -a, all the spelling container images you can see. Docker PS, it is only going to show what is the running container. And if you say Docker stop name of the container, it is going to stop that particular container with the name Dilip. And if you say Docker rm Dilip, it will delete the container with the name Dilip. Okay. So far, so good. Can we have a 5-minute break and then we move to a part which is DevOps topics to explore, and then we end our today's session. So you want to take a 5-minute break? We want to continue. So we take a 5-minute break and then we continue. Okay, one saying continue, one saying break. So I take a 2-minute break and I come back. Okay, 2-minute break. 3:43, I'm back. Welcome back, student. So what is this DevOps is about? So why it is important? If you see DevOps, Singapore has the same population as Norway, 5 million, around 5.2, 5.5 million. And if I just search DevOps on a LinkedIn is not a primary job searching platform. You can see there are 2,700 jobs only in Singapore. And DevOps has become very important. In the past, what the task many people used to do, and DevOps engineers are doing it with a less number of people. And if you search Docker, you can see 1,500 jobs have a requirement of Docker. And then, sorry, this is safe. Sushi safe is coming. Like if you say Jenkins is one of the Docker DevOps tool. You can see 1,200 jobs has a requirement of people knowing a Jenkins. And that's why I am taking you to do today's this topic. So this is not part of our cloud and big data technology course. Only telling Docker and then stopping may not help you explore your curiosity. So I'm just going to give a brief overview of DevOps, and also the topics you can explore if you want to learn more about it. And after knowing this thing, you will be able to get, I think you can yourself, whoever is interested, can explore the topic on DevOps. So if we think from the software development lifecycle point of view, what it is that there is a developer, right, who's developing, then he's building, and then he is going to test it and then do quality assurance, right? And then it is going to send to the test site, then it is deployed, then it is maintained, and it is monitored. So this is in general what happens without even thinking about DevOps or anything. Any software development is going to have this kind of stages: develop, build, test. So what used to happen that developer has developed something and it passed to the build team. Build team will say, okay, not good, not have building, I'm not able to build it. It is again going to give back to developer, and then build team is going to again build it with changes, and then build team build it, then it is going to send to the test team, then test team is going to test whatever developer has done. Test team will say, no, I am not able to test it because it is not running. It is going to send it, then again developer is going to say, okay, no, change it. Then it is again built, and then once build is done, then it is going to pass to test, and the test team is going to give it to quality assurance team, and then QA team is, if it is able to run it well or able to know it, it is going to say okay, and then it is going to be deployed. And in deployment state, again, then maintenance team is going to find, if it is not able to do it, maintain it, is going to go back. So all this was happening. So there was a development side, there was this operation side, constant bickering. And when I was working in a software company, this is what the environment was. We developed something, the build team is not going to build it, because in the build team, they are keeping the central repository, they are doing this proper configuration management. So at every stage, a lot of staff needed, and it was becoming a delay, lots of delay, fight. Means on the date of release of the software, before that 1 week or whatever day they take to actually for release time, constant fighting is happening between the development and operation team, So this is what generally it was. When that problem is getting solved by the DevOps, and if you go with a DevOps lifecycle, then also you have a plan phase, code phase, build phase, test phase. And this cycle I was telling you, when you will learn, if you learn software engineering, there is a waterfall model. My handwriting is bad on the tab pad. So waterfall model, where stage by stage you do it, but then later on people move to the agile model, which is build and test, and continuously increase the software development. And then there is someone has to integrate it, whatever this side of the people are making, and so that the operation side can deploy, operate, and monitor. To do this, lot of apps are there, lot of this whole environment is there, and this is what you call a DevOps lifecycle. It helps things speed up, but then for every different phase you have a different kind of thing, like Git is there, then you have Maven to build, and you have Selenium to test or JUnit to test, and there is a Jenkins which does the integration. You have Docker to deploy, you have Chef to do configuration management, then you have NAG EOS to do monitoring after the deployment phase when it is in a production side. For all this, there are a lot of tools are there. You don't have to be master of all the tools, but having knowledge that how development and operation cycle works and having little bit idea about each of the basic tool, which is basically, if you want to explore further, if you have an interest, so Git is used for planning and coding. Like you have probably used GitHub to actually pull the code and run on your platform it runs. So that is a Git. So GitHub and Git is a different thing, but Git you are going to learn in the software engineering course if you are attending that course. Then there's a Jenkins, which is for continuous integration tool. And there is a Chef, which is a configuration management tool. There is an Ansible is there, deployment tool. There is a Maven, which is to build automation tool. And there is a Selenium for testing automation. And NAG EOS is a continuous monitoring. If you want to explore further and have interest in DevOps kind of jobs, you don't have to, but like if you go in a company, you are not going to work everywhere. Either you are going to be in the planning stage or in the coding stage or in the build stage, but having the knowledge how the deployment tool in general works, how the operation tool in general works, or how the build tool in general works, or test tool in general works, will help you have sort out if any time any problem is happening in any stage, and you get a feedback, okay, you have to check into, then you can able to tell, okay, that might be happening because that particular tool, which deployment tool is running, have this kind of basic component. You don't have to master on it, but having a little bit of knowledge of this thing will be useful if you want to explore the position in DevOps kind of platform. I have said that DevOps is coming like this. You have this plan, build, continuous integration, deploy, operate, continuous feedback, continuous feedback. Here is a dev, this side is ops, and this is continuously happening. So some of the tools you can explore like Git, GitHub, GitLab, Docker is there, which you have learned it. Puppet, somewhat getting common. Then you have Kubernetes, Selenium for testing platform, and Jenkins for continuous integration. So there are this DevOps world, lot of things are there. You don't need to know. More or less, these platforms are pretty easy if you know a little bit of it. Something you will know, like Git and the Docker, you already learned it. Some other, you may learn it somewhere. If a modern advanced software engineering course is there, then they should be taking you through the different DevOps thing if they want to focus on the DevOps kind of education. And then there are a lot of things are there for your, in this DevOps world. This is whole ecosystem. You don't have to, you may hear it, but practically I have given you what they mean for. You don't have to know all this test automation tool. You know a little bit Selenium, which is famous, Docker, Kubernetes, which is famous. Now, coming back to it, when I am telling you this, right? Let's say, this is important. When I'm telling you all this, so all this tool you see, right? These are all open source thing. What I'm telling you, these are all open source. But if you go to Azure or AWS, if you say Azure DevOps or Azure DevOps, this DevOps is not this DevOps. These are all free one. Azure also have DevOps like Artifact, plan. AWS also have code, execute. No, they have many DevOps tool for doing all this plan, build, and this kind of activity. But that DevOps, AWS DevOps and Azure DevOps is different from this. Usually a company, let's say a big company like Adobe, right? They would not like to get dependent on one kind of environment. So they internally in the company, they actually use this kind of tool instead of Azure DevOps or AWS DevOps. So if you go work in any development company, they are practically not using Azure or AWS DevOps. If it is a product makes company, they are actually using this kind of DevOps tool. And these DevOps tools are doing the similar task what Azure DevOps or AWS DevOps will do. So this is very important to clear. If you see a job like Azure DevOps, so they are actually talking about the DevOps option available in Azure. But if you are generally talking DevOps with Jenkins, Ceph, and Ansible, they are talking about this open source free tool to use it. Is that clear? Any question you have? So DevOps you can explore after Docker if you want to do